Before you watch this video, make sure that you've already watched the stoichiometry video and know how to convert between grams of one substance to grams of another. In this video, we're going to talk about theoretical yield versus actual yield and the difference between the two. Theoretical yield is the maximum amount of product that should be produced in an ideal situation. It's the value that you calculate whenever you're doing a gram to gram problem. So in the stoichiometry videos, all the 4 examples that we worked, every answer that we get, those are the theoretical yields. That is what you're supposed to be able to get out of the reaction. Now, the actual yield is what actually happens in a reaction. So not all chemical reactions are perfect. There might be some reason that your product doesn't come out to the amount that you're supposed to have. But the actual is the experimental value. It's what happens in your lab. When we're doing calculations, this will be given to you in the problem. Now, if you measure your actual yield and then you calculate your theoretical yield from a stoichiometry problem, then we can calculate percent yield. And so what percent yield does is it compares the amount of product obtained from a reaction with the amount that should have been obtained. So it's trying to see how efficient your reaction was. And it's a really simple formula. It's actual yield divided by theoretical yield times 100. We're going to work an example here right now. A student makes 13 grams of potassium chloride in a lab. After calculating the theoretical yield to be 21 grams, what is the percent yield? So first thing I'm going to do is write down my formula. Percent yield is equal to actual divided by theoretical times 100. We're going to go back and look at the problem. A student makes 13 grams of potassium chloride in a lab. That's our measured amount, 13 divided by the theoretical yield is 21. So that's what the calculated one, or the calculated amount was. As you can see on here, we didn't get the full amount. If we had gotten the full amount, then that would have been a 100% yield. So what we're going to do is go in our calculator and we're going to do 13 divided by 21 and then multiply that by 100. And that's going to be our percent yield. And that's going to be 62%. Now we're going to try and see if we can calculate percent yield from an equation. But before we can do percent yield, we've got to start with calculating our theoretical yield. So before I even begin the problem, I got to make sure that this is balanced. And it just so happens that it already is balanced, so everything is going to be a 1 on this one. I began this reaction with 20 grams of lithium hydroxide. What is my theoretical yield of lithium chloride? So this is a gram to gram problem. This is stoichiometry right here. We're going to start with 20 grams of lithium hydroxide. We're going to bring grams of LiOH to the bottom. We're going to go to moles of LiOH. 1 mole of that, and then we're going to look up our mass on the periodic table, which is going to be 24. Grams is going to cancel out, and then that's going to leave me with moles of LiOH. I'm going to continue by bringing that down, moles of LiOH. And since we're trying to get to lithium chloride, we're going to go to moles of that. I see mole over mole. Reminds me to go get my mole ratio, which just happens to be 1:1 for everything here. Moles cancels out. Leaves me with moles of LiCl. But we need to get to grams. So moles of LiCl to grams of LiCl. Right, 1 mole, and then we're going to look up our mass on the periodic table, and that is 42.4, and then moles is going to cancel out. Last thing we need to do is multiply the top and divide by the bottom, and that's going to make our answer 35.333 repeated, but we want to use significant figures, and that is grams of LiCl. So way back here, since I don't have a decimal, I only have one significant figure. So we're going to round 35.333 to 40 grams of LiCl. That is my theoretical yield. That is how much I'm supposed to be able to make. Now I actually produced 6 grams of lithium chloride, what is my percent yield? So this means if I went and did this reaction in a lab and then I measured it and I only calculated 6 grams, then I want to know how efficient my reaction was. So percent yield is equal to actual, which was 6, divided by theoretical, I'm supposed to have 40, times 100, and then that's going to give me my percentage. So my percentage in this one is 15%. So it's not a very efficient reaction. We're going to work one more example here. Before I can do anything, I need to make sure this is balanced. So up here I see one Fe on the left, 2 Fe's on the right. I'm going to make that 2. That's going to give me 2 PO4s. I only see 1 over here, so I'm going to make that a 2. That's going to give me 6 NAs. I only see 2 there, so I'm going to make that 3. And then 3 SO4s, 3 SO4s. We're balanced. And I'm going to go ahead and write my 1 in here. Now, if I perform this reaction with 25 grams of iron 3 phosphate and an excess of sodium sulfate, how many grams of iron 3 sulfate can I make? Whenever you see excess, what that means is that you have more than enough of the other reactant to ensure that your 25 grams is going to react to completion. So if you see excess, just ignore that other reactant. That's all that means. We're going to start with our given, which is 25 grams of FePO4. And so I'm going to go ahead and bring that down to the bottom, grams of FePO4. We're going to go back to moles of FePO4. And so for this one, we have given you the molar mass just to save you time. And so we know that the molar mass is 151 grams. Grams is going to cancel out. Moles of FePO4, we're going to bring that down. And we're going to go back to moles of whatever we're looking for. So in this case, we're looking for iron 3 sulfate. So moles of FeSO4 3. And that's the mole over mole. I'm going to circle that. And I'm going to go back up here and look for my coefficients. So Fe2SO4 is going to be 1. And that actually should say Fe2 right there. And then FePO4 is going to be 2 for that. Moles is going to cancel out, and that's going to leave me with moles of FeSO4, Fe2SO4 3. And then I need grams of that, so we're going to bring down moles of Fe2SO4 3, and then finally go to grams, which is going to happen to be 400. So 1 for that, and then we can multiply the top, divide by the bottom, and that's going to be our theoretical yield. That's what we're supposed to make for this problem. That's 33.113, but we want to round that to significant figures. So I started with 2, and we're going to make that, this is going to be 33 grams of Fe2SO4 3. That is my theoretical yield. So now, if we look here, we can calculate our percent yield. So actual yield for this one, if 18.5 grams of iron 3 sulfate are actually made when I do this reaction, what is my percent yield? What we can do is set that formula up as actual divided by theoretical. So 18.5 divided by our 33, and then times 100. And then when we plug that into the calculator, we are going to get 56% as our answer. So this had a percent yield of 56%.